over it day. Get over it day. It's halfway, fun fact, it's halfway between Valentine's Day and April Fool's. So that's today, March 9th. And it was created by Jeff Goldblatt, no idea who that is, in 2005, because he was having trouble getting over an ex-girlfriend. And he was like, man, I just need to get over it. And so he invented this day, and it's kind of silly. So yeah, kind of fun. Yeah, so question, what is it that you just need to get over, right? Like I woke up with some neck pain for the second day in a row, and I was feeling kind of spicy about it, like mad. And then I was like, you know what? I need to just get over it. It's going to be a great day anyway. So today is all about getting over, getting over when Ariana Grande was robbed of all 5 Grammys that she was nominated for. That's something that like maybe we just need to get over today. Yeah, I don't know. You know what we don't need to get over though? What we don't need to get over, what we need to celebrate is Kat's birthday. Kat, happy birthday! It is Kat's birthday today. Kat, how old are you turning?
I'm turning 17. And
17.
thank you.
Amazing. You're welcome. Are you doing anything fun for your birthday?
No, on Saturday I went to Fontana to celebrate with my dad's family. And then today we're gonna celebrate with my mom's family at my house. And yeah.
Amazing. That's awesome. 2 celebrations. That's super fun. So happy birthday. The chat is also pulling you up. So happy birthday. I am pumped that you get to share your birthday with Get Over It Day. You got to be like, get over it. It's my birthday. You can't be crappy today. It is what it is. So for sure, Kat, thanks. Cool. Are there any questions about our day before we move on? Any questions? Welcome. All right, friends. We have our agenda today. Announcements, notes, assignments. Pretty simple. This is the last week that we're going to make that happen. We'll have assignment 31 will be today, and then I think we're going to have assignment 32 on Thursday. I have not yet decided. It won't be a quiz or anything. I just haven't decided if we need to like review or if we're good to push forward. So I'm going to take a look at like how things go today. And then next week, we're going to be setting up our PT. You'll have 4 PT assignments brought to you by our TAs. It's going to be awesome. It's like adulting one-on-one, like some financial literacy, like saving, budgeting, credit, debit, investing. I know some of us do a lot of that, and some of us haven't done too much of that yet. So super pumped to have that. After that, just 3 short weeks to spring break. We can do this, friends. We're going to make this happen. So we will hit that up. Just a reminder, since there are 3 weeks left, I put our last 3 assignments up here. If your name is up here, you need to either submit or resubmit. So please take a look at that. I know sometimes it's hard to like look at the comments and whatever. So I wanted to just flag it for you if you needed to submit or resubmit. I will close modules in week 11, Wednesday of week 11. I don't know the exact date. If someone wants to look up the exact date of Wednesday, week 11, that would be awesome. But that will be when my modules close. But for right now, everything's open. Quiz corrections, like totos, everything's open. So you can like make that happen. The 24th of March. Great. That's when my modules are closing, 24th of March. Thanks, Gal. Cool. Any questions about module closures, end of quarter, anything? Negative? Cool. Thanks, Jimmy. All right, let's jump into our notes then. I think we are going to rock and roll. Jump into our notes. Let me know via la poll how much time you need. So let's relaunch this. Let me know, are you ready to go? You got paper, pencil, or like the computer thing open? Or if you need a moment to get ready, I'll go ahead and pull up my notes here as well. Hi, Miss Ramon.
Hello.
All right, friends. We're on notes 31 today. I'm gonna give people space who asked for a minute. So we'll wait a little, like 30 more seconds here. Breakout rooms are open if you would like to do team video today. So I know Maritza's already jumped in there. If you'd like to be team video, you're welcome to jump in. You should have access. If you don't have access, let me know, and I will pop you in to a breakout room if you need it. Cool. All right, team, let's jump in. Today, we are going to talk about degrees and radians. Did anyone watch my cool video I sent last day? The like background video? Yes, at least one person did. A couple people did. Awesome. Yeah, it was pretty interesting, right? For anyone who has ever been like, why the heck do we have 360 degrees, right? I thought it was a really cool, interesting story because I was like, yeah, I didn't know I was wondering that, but now I am wondering that. Like, why 360? So I sent out a video. It is also attached in your notes, so you can check that out. And it's basically the answer is like, it was just a lucky number, right? It was a lucky number. Had a lot to do with sailors, right? So sailors using the stars, they recognized that the stars started to repeat themselves 360 days later, right? And it was really 365, right? They were going all the way around the sun. And 360 is just like a nice number. It's divisible by 1, 2, 3, 4, 5, 6, 7, 8, wait, maybe not 7, 8, 9, 10, 12, 15. It's divisible by so many numbers that it's super, super helpful for doing mathematics. So it's just literally a lucky number. So that's how we got 360 degrees, right? You can feel free to check out the video. Today, we're going to spend a lot of time talking about radians. Radians. Have we used radians before in our previous math classes? Or is this going to be like totally new to us? Seems new. Cool. Okay. Looks like we got some newness. All right. So let's talk about what a radian is. Okay. A radian feels like a unit, like degrees versus radians. It's technically a non-dimensional unit. It's technically not a unit, but we're not going to worry about that. Like that's like math theory for right now. So here's the idea. If we have a circle on our page, wow, that's a terrible circle. Let me try again. I have this tool. Yeah, perfect circle. Great. Now I'm going to move it. All right. So let's say I have a circle like this, right? So if I have the radius, right, something that we might notice, if I have the radius from the center to the outside, that distance right there, if I take this distance and I lay it on the outside, it goes about this far. Goes about that far. So that's my first one. And then I do my second radius, and it goes about this far. Right, so this is one radius. This is my second radius. Right, and then if I go another radius, I get about this far. This is my third radius. Does anyone have any guesses how much more of a radius sits in this little piece all the way to this here? Any guesses? We have 1, 2, 3, and then a little bit more.
I think there's 8.
8? Like you think like 8 more?
Oh no, like 8 in total.
Oh, 8 in total. Oh, good question. There's not quite 8. There's a little bit more than 6. What would, okay, think about a fancy math number. A fancy math number that's 3 point something. A little bit more than 3.
Pi.
Yeah, pi, absolutely. And good job, Jonathan, too, in the chat. This is 0.14, 0.14, 3.14, 159, you know that number? Pi. So in 180 degrees of the circle, in a half circle, there is pi radiuses, which we are actually going to call radians. Radians are like they're kind of like a distance. We're going to use them as a unit for right now, even though technically they are not, but we'll get there later. So this is pi. So then if halfway around the circle is pi, how far is all the way around the circle? It would be another pi, right? So 360 degrees is the same as 2 pi radians. For sure, 2 pi. So 360 is 2 pi, and 180 is 1 pi. 180 is 1 pi. What if I only wanted to go 90 degrees? What if I only wanted to go 90 degrees? What would 90 degrees be? How could I talk about that in radiuses, in radians? Yeah, pi over 2. Pi over 2. So that's one of the big four. Pi over 2 is equal to 90 degrees. If you have nothing else on your paper, I want you to make sure that you have what I put in these purple boxes. Pi over 2. So when we have pi over 2 radians, that's equal to 90 degrees. What if, I'm going to go ahead and clear up my circle a little bit here. Okay, so if 90 degrees, that's pi over 2, what would 45 degrees be? Yeah, Jonathan, you're doing great. 45 degrees would be pi over 4, right? Pi over 4. If you think about it, if I'm going to get to 45 degrees, there's 4 of them, 1, 2, 3, 4 in that circle, in that half circle, right? This is pi, and we're splitting it into 4 parts, 1, 2, 3, 4. So 45 degrees would be pi over 4. Pi over 4 is 45 degrees. All right, pi over 2 is 90, pi over 4 is 45. Let's think about splitting them up in a different way. Let's say I still have my 180 degrees, but this time I split it into 3 parts, right? I have 1, 2, 3. 180 divided into 3 parts, that would be 60 degrees each, right? So this is 60 degrees. How would I write that in pi, in radians? What would this be? I did pi and I divided it into 3. Yeah, so 60 degrees would be pi over 3. So pi over 3 is 60 degrees. Pi over 3 is 60 degrees. All right. So then the last one, if I'm going to divide this in half again, another important one that we have here sometimes is 30 degrees. This would 30 degrees would be pi over, yes, Jonathan, pi over 6. Pi over 6 would be 30 degrees. If you think about that, that's because like we would have all of these sections here, and we'd have 1, 2, 3, 4, 5, 6 of them. So 30 degrees would be pi over 6. Whew. All right, so we have our big 4 here. The reason I call them the big 4 is because those are the easiest things to memorize, right? I would just honestly, we have to memorize them. I don't love doing a lot of memorizing in math. Contrary to popular belief, I think like most mathematics makes sense, right? As long as we deeply understand it. These also I think make sense as we talked about them here, right? But these are ones that will be helpful to us if we can memorize them. Pi over 2 is 90. If you think about pi as 180, you could just do 180 divided by 2. Oh, that's 90. 180 divided by 4. Oh, that's 45. 180 divided by 3 is 60. 180 divided by 6 is 30. Right? These are big 4 here. I'm going to throw a poll to you. This can be really challenging, right? This can be really challenging. So I just would like to know, how are you feeling about that part there? Just about what we've talked about so far. It can be really challenging because our brain is already in this degree mode, right? Our brain's in degree mode. And we're like, but why would we need to think about another way? And the way really is that degrees are really helpful with 360, but because it was just a lucky number, it doesn't give us the degree of specificity that we want, right? It doesn't get as specific as we want. So with radians were directly created for circles, right? Directly created to talk about a circle and uses that radius that we were talking about. And that's why they're more specific. And this is largely what engineers use. So if I have any future engineers out there, I want to make sure that we're getting there. Right? Great question, Jonathan. Jonathan's question: do we have to change our calculator for these problems? Yes. If you are doing a problem with radians, you want your calculator to be in radians. If you're doing a problem with degrees, you want your calculator to be in degrees. Okay. So we are going to, in this next portion here, I'm gonna go ahead and end our poll. I'm just gonna show you where you're at. You are, no matter where you are, no matter how much you're like feeling this or not feeling this, there are other people like you, right? So we have a lot of 2s, a lot of 3s, a lot of 4s, and a lot of 5s. So you are not alone no matter what your level is. My goal is to help us get to feel more confident here. All right. So for example 1, we are going to do the same things that we've been doing with degrees, but now we're going to be doing them with radians, right? We are going to draw the given angle. So this is our angle here. We're going to draw it in the appropriate quadrant. We're going to label it using the radians that they told us and the degrees. And then we're going to label what's called the reference angle, right? And we're going to label that in radians and degrees. So we're doing a lot of labeling on the thing here, right? We're not doing like a lot of like mathy math right now. We're doing a lot of labeling. So let's look here first. So our theta, our angle, is 3 pi over 4. The way that I'm going to think about this is pi over 4. Pi over 4 is one of the ones that I memorized, right? One of the ones that I memorized. It's 45 degrees, pi over 4. And I have 3 of them. So this is 3 times pi over 4. 3 times 45. Anybody got a number for me?
135.
135 degrees, right? So 3 pi over 4 is the same as 135 degrees. So I'm going to go ahead and draw this line over here because I have 45, 90, and another 45. So this angle here is 135 degrees, and it is also 3 pi over 4. Seeing some questions. What if the 3 would be next to the fraction rather than next to pi? If the 3 was in front, right, we would have the same thing. It would still be 3 times pi over 4. Right, so this 3 could be in front and be multiplied, or it could be on the numerator and be multiplied. It'd be the same thing. Okay, so this is our angle. We drew the given angle in the appropriate quadrant. The second step was to label in radians and degrees. We did that. And then our next step is to label the reference angle in radians and degrees. So we're learning a new word here, which is reference angle. The way that we say it is we talk about theta, but then we put an R down here, right? So this is angle reference, right? So reference angle. The reference angle always between 0 and 90, right? And it's just the distance from the line to the x-axis, right? So we don't want to go all the way back here, right? This right here would be our reference angle. if you think about it, like if we were going to draw that triangle, right, you're talking about like, what would this angle be? That's your reference angle. So for 135 degrees, our reference angle is over here. It's basically like, how many more degrees do I have to get in order to get to 180? So let me ask you that. How many more degrees, if I'm at 135, how many more degrees do I have to get to 180? Good job, Diana. Good job, Gally. Right, so this would be 45 degrees. And it asked us to list it in degrees, but also in radians. What is 45 degrees in radians? Pi over 4, yeah. Pi over 4, great job. There was a question, will the reference angle always be one of the big four? For our problems today, yes, right? But not in real life. So in real life, we might have, let's say our reference, like our angle was 42 degrees. Our reference angle would be 42 degrees, right? So for this problem, our reference angle would be the same as the angle itself, 42 degrees. Let's say that our angle, let's say our angle was 110 degrees. Then our reference angle would be how much further it is, right? That would be 70 degrees over here. For today, since we're practicing the transition between radians and degrees, they will all be one of the big four, right? Or they'll use the big four in their calculation. But in real life, no. Let's say our angle was 205 degrees. Call it 205. That's all the way around here like this. Our reference angle would be this portion here. And it would be 180. So I'd subtract 180 here. And that would give me 25. This would be 25 degrees. But for today, our reference angles will all be one of the big four. Okay, good question. All right, let's go ahead and try this one here. So we have B. All right, if I have 5 pi over 3, I have pi over 3, that's one of the big four. How many degrees is pi over 3? Yes, we have 180 divided by 3. I would have 60 degrees times that 5, right? So this would be 300 degrees. What quadrant, 1, 2, 3, or 4, what quadrant would this angle be in? Yeah, 4, good job. It's gonna be in 4. It's all the way over here, all the way over there. So I have 300 degrees. I'm also labeling it as 5 pi over 3. And then how much further would I need to go? What is my reference angle here? Yes, 60 more degrees, right? 60 more degrees to get to pi, or to get to 360. And then we would, what would we call that in radians? Looking for a couple more answers. So our all the way around would be 2 pi. All the way around would be 2 pi, but for the reference angle, we're just talking about this little baby portion. So I already went 5 pi over 3. So I went 1, 2, 3, 4, 5. And I would need another one, a 6th pi over 3 to get back here. So I'm thinking, okay, 60, it's one of the big four is pi over 3, like that. So 60 and pi over 3 are equal to each other. For sure. So my angle itself is these two, 300 and 5 pi over 3. And my reference angle is 60 degrees, or pi over 3 radians. Okay. I'm going to relaunch this poll real fast. How are we feeling about what we got here? How are we feeling about these two? That's not a real poll. My bad. Hold on. How are we feeling? Take about 10 more seconds, button that poll. Yeah, sorry about that first poll. All right, cool. All right, it looks like we've got some 2s, some 3s, some 4s, some 5s, largely 4s. So feeling pretty good. Let's go ahead and work with this one here since it is negative. I'm going to skip D and we'll do that. You can check it out in the video if you want. So I just want to highlight here, you'll notice these two problems are like nearly identical except for the negative, right? When they give us a negative angle, all it means is that we're moving in the opposite direction. So with a positive angle, we move in a counterclockwise direction to our angle. When we're in negative, right, we're going to move clockwise from 0. Right? We're going to move clockwise from 0. So if this is 0 here, normal positive would be that way, but we're going to move the opposite direction. So pi over 4, I know it's 45 degrees, times -3. This is going to be -135. So I am moving this direction over here. So my angle would be -3 pi over 4 or -135 degrees. And then what would my reference angle be? Love to hear from someone I haven't heard from yet. What would my reference angle be? Ah, good thought, Brandon. It actually is not negative, but you are correct. It is 45 degrees. But I love this idea. I hadn't thought about that. It's not negative because the reference angle always refers to the like triangle, like it's like absolute value, right? It's going to refer to that angle no matter what quadrant it's in. So even though we moved in the negative direction for theta, right, our reference angle will always be positive. So things we're learning about this, our reference angle is always between 0 and 90 degrees, and it's always positive. Two things we like. All right, what is 45 degrees in radians? Pi over 4. Yes, pi over 4. Good job. Thanks, Diana. Thanks, Callie. Thanks, Kayla. All right, between 0 and 90. All right, so that is our angles in radians and our big 3, right? Our reference angles with our big 4. All right, if you would like to see this one, you're welcome to check out the video, but it is largely the same thing. Pi over 6 would be 30, multiplied times 7, this is 210 degrees. Yeah, map it out just like that. So you can check out the video if you want that one. I do want to talk about example 2, which is converting directly from a degree measure into radians or from radians into degrees. And we talked about like the big 4 and their relationship here, but I do want to just show you how to do it if you just have like a straight degree number. So let's talk about 300 really fast. Do we remember chemistry making something that looks like this? Like I think it's called stoichiometry in chemistry. Like where you're converting from one thing to another. Gallia, it's called stoichiometry? Yes, great. Okay, so in stoichiometry, remember how like the top and the bottom, they're equal to each other. They're just changing the units, right? So we know that pi and 180 are equal to each other because of like the math that we were doing at the beginning. Pi and 180 are equal. So if I want to cancel the degrees, I put the degrees on bottom, and then I put pi on top like this. So I'd have 300 times, remember this would be like over 1. So 300 times pi would be 300 pi over 1 times 180 is 180, like that. And then I would say, okay, I can cancel out 10. 30 over 18, I can take 6 out of both of those. So I would have 5 pi over 3. I divide by 6, divide by 6. So I'm just simplifying at that point. So 300 is the same as 5 pi over 6, over 3. 5 pi over 3. I can quickly check that. Pi over 3, I know is 60 degrees. 60 degrees times 5 is 300. So I can also think about it like that. Right. Go ahead and try. I'm going to actually change. Oh no, let's do 150. Let's do 150. It is easier than it was explained in chemistry, I guess you. So again, I'm going to put 180 on the bottom. 180 degrees is the same as pi radians. So I'd have negative 150 pi over 180. Brandon, yes, it's always 180 because that's what pi is. So pi, right, remember a half circle is 180 degrees, and it's also pi radians. Right, so it has to be 180 because that's what's equal to each other. When we do this step, all we're doing is multiplying times 1 because pi over 180 equals 1. They're equal to each other. It's like 10 over 10 or 5 over 5 equals 1. So yes, it is absolutely like has to be pi over 1. Yes. Diana's got me. She's already simplified. Divide the zeros cancel. Divide by 3. Divide by 3. Diana told me negative 5 pi over 6. Again, this makes sense to me because pi over 6 would be 30. 30 times 5 is 150. So we can get back to our 150. So, yes, Kayla. Yes, Diana. That's perfect. This is our answer here. Okay, so we've done 2 examples with our like degrees. I want to also do 2 examples with our radians in our last 4 minutes here. So if I have pi over 12, if I want to cancel the pi, if I want to cancel the pi and turn it into radians, I need to put the pi on bottom. So pi is on top here. I want pi to be on bottom here. What is pi equal to? It's equal to 180. So again, I'm always going to use 180 and pi. These are equal to each other, right? So I'm just multiplying times 1, another version of 1. So in this case, I would have 180 pi over 12 pi, right? Pi's are going to cancel. 180 divided by 12. I could do it on a calculator or I could simplify, but basically I'm going to divide by 12. Divide by 12. 180 divided by 12 is 15. Yeah, it's 15. And so my pi's are gone. It's 15 over 1, so it would just be 15 degrees. So pi over 12, super small, right? If you think about like taking my pi and splitting it into 12 pieces, like this, and then like, you know, ooh, so many small pieces. One more, 12 of them. This section here would be just 15 degrees. For sure. Okay, go ahead and try, F, 5 pi. 5 pi, what would that turn into? I'm going to put pi on bottom because I want it to cancel. 180 degrees on top. So I'm thinking, okay, pi and pi are canceling, and it's just literally 5 times 180. Anybody know my number?
540 or
540, yeah.
720. Oh, okay.
I don't remember. 18 times 5 would be 72, so 720. Does that seem right? No, that doesn't seem right to me.
It's 90, not 70.
Ooh, thank you. 90. 900 degrees. Okay, so if we're thinking about 900 degrees, thank you. I don't know who just came off mute, but I appreciate you. This is what's happening here is we're going around and around and around. Thank you, Kayla and Diana in the chat too. So we have 360, and then we have another, oh, I did not want that to. So we have 360, and then another one is 720, and then another one, that would be 900 degrees. And if you think about it in radians, we'd have 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, and that would get us to 5 pi. And these are equal angles to each other. So angles can go like around and around and around the circle. They can get like really, really big, right? But these are the same. So 5 pi is the same as 900 degrees. Okay. On that note for today, you have a couple more options. Like people were asking for extra examples. So you do have 4 more examples in the video if you would like to check that out. For your homework for today, we're going to be doing largely the same thing. So you have, this looks messier than it is. I cleaned it up for your document. You have 6 problems where you're mapping it out like we did in example 1. And then you have 9 problems where you're converting like we did in example 2. And you're done. Just kidding. Then you have 1 more section here where you're like converting it here and determining where it should be. Okay, so you have 3 sections here today. If it's taking you longer than 45 minutes, please do let me know, and we can make adjustments as necessary. But you should be good to go. It should not take any longer than 45 minutes. That being said, it is 10:30. I want to let you go. I hope you have a great Spanish and science class today, and I'll see you on Thursday. Bye, friends. Bye. Take care. Bye. Have a great day. Bye, y'all. Bye, everyone. You're welcome.